Hi, my name is Kai Stinson, and today we're going to be talking about using computer algebra software to discuss an algebra concept that you can find commonly in Math 1 Unit 4 in the NC curriculum, which will be typically taught to freshmen and sophomores, and specifically we'll be looking at logistic functions. The logistic function is in the form that you see here, where f of x equals a over 1 plus e to the negative b times x minus c. And we're going to go over 4 questions which will help demonstrate my skills that I use to explain mathematical concepts in a digital program or space. Let's begin. So question 1 I have is using a graphing tool to explore the effects of the parameters a, b, and c on the graphing function. And I'm going to explain the effect of each and why that makes sense. So let's take a look. If we take a look, we have 3 parameters, a, b, and c. These are our parameters, basically, or as commonly converted to as parameters, or our variables. A variable being that a number that will equal something in the formula, in our form of f of x down here. So we're going to take a look, and we're going to see which one does what. So if we take a look, b and c, when edited, we can't really see much. Now, unfortunately, I had a at 0.1, so you can see a little movement here, but imagine that was at 0. And if I move a, I'm going to put a at 3. There we go. And you can see 3, it stops right here. Then it goes straight, and it doesn't go over 3 at all. And we'll revisit why that happens later. But for right now, I want to focus on b and c first. And b, if you edit b, you can see that it's acting as y-intercepts. C is, as you can see, controls where the line's going to cross, and b controls the slope, but both lines respectively are crossing the y-axis. Note that neither of them, no matter how much I edit them, will force the line to go underneath or go below the y-axis. That is controlled by a different parameter. Quick side note on that, if I edit a, you can see, and I make it negative 3, now they're below. So a controls basically where our lines, y-intercepts, will basically be either positive or negative. So, in terms of their sign, their given sign. In this case, however, c and b are our y-intercepts, as I stated before, and will always cross the y-intercept line at some point. How that happens is just edited depending upon that, and b is acting as a slope. Now, let's go further into the exponential part of e. This form look very familiar, and it resembles that of the equation of a given line, being the fact that this means that c is our metaphorical y-intercept and b is our slope. This is good to note because it makes it easier to visualize what's going on in terms of what each parameter controls. So that's why these 2 variables make sense in what they're doing. One's acting as our y-intercept, and one's acting as our slope for our logistics growth and decay function, but it's also as in a sub sense acting as a slope for the exponential part of e. Now, it is worth noting that the negative exponent, which inverts, typically depends on the size of the base. So, typically speaking, if it was an e and was something else, that will determine whether or not it also can invert. But luckily, it's an e. We don't have to worry about that right now, so we're not going to go into detail on that. Let's go ahead and look at question 2. Question 2 gives us another function, which I have wrote in terms of g, that states that, and I'll say it in terms of that, g of x equals 2 over 1 plus e to the negative x. Model logistics, growth, or decay. Question basically is asking which it is. Is it a growth or decay model? Well, since we've edited this graph so far, we've seen a few examples of what determines if something has growth or decay. And as you can see, the real big influencer on this is our slope in our exponent for e, which is the parameter b. Therefore, if we go down here and look, we can see that it is a negative x. So I would make the logical prediction that g of x is a positive growth. And here's why. Even though b is negative up here and the line's decaying, that means that that a had to have been, in some way, shape, or form, or yeah, b would have been positive. If it was negative, it would have caused the exponent to go from negative to positive, because a negative times a negative would have given you a positive. And we also then assume that c is a value that is greater than well, any value, honestly, for c, as it's like of the y-intercept. We're concerned with the slope, not our y-intercept. So b is, in short, in order for this to have a positive growth, which, as our prediction we made was true, b has to have, in some way, has to have a value that is typically going to be greater than 1. If it's anything less than 1, it will have a negative decay, or it will have a decay in the function. Now, let's look at question 3. Which parameters of a, b, and c determining limiting values? Limiting values, what that is referring to is horizontal asymptotes. Now, horizontal asymptotes are a kind of specific y-intercept. They act like y-intercepts, but they're basically, as I like to refer to them as, invisible walls. They act essentially as constraints where it prevents the function from crossing a line. Now, as I mentioned earlier on question 1, we're going to revisit our variable a and why I said I wanted to wait on this. A, as you can see, if I edit it, controls how much, what's the maximum growth that's possible, or decay, if it's negative, of our logistics function. So that right there, you're seeing is me. I'm actually changing the asymptote of the function, and that is the quote-unquote limit that the function is able to approach infinitely. So what I refer to that is, if let's say I have it at a, that means that my function f of x has a limit as a approaches 4, meaning that as it approaches 4, it will never ever cross 4. And the same can be said for the reverse direction, where I can say the limit as a approaches negative or 0, it will never cross in that direction. Now, that, however, doesn't necessarily mean that I can edit this part of the function. In order to edit this part of the function, it requires to edit a different variable, because I don't have a slider for it, so we're not too concerned. However, I would not have used a. I probably would have used another parameter like d or e. I mean, sorry, not e, because we have our exponential value in here. So I probably would have used d. But semantics. Moving on. For our last question we have, for any logistics function, without graphing or using a table of values, how can you determine the value at which the rate of change of the function switches from increasing to decreasing, or vice versa? This is an old concept that we have to... This question can be answered with a very simple old concept. If you go back to trigonometry or any kind of graph, and you look at wherever the value of the slope changes from positive or from positive to negative is what you're looking for. Now, this is how we can determine, without graphing points or finding a bunch of values, how we can determine that. Because if we notice how the graph changes over an axis, and we calculate that change, it will tell us if the slope is changing from a positive to a negative, or from a negative to a positive, vice versa. Now, in terms of this specific form of the logistics function, it would be harder simply because we're not anywhere crossing the x-axis, as our horizontal asymptote for that bound, unfortunately, is on the x-axis at 0. Now, if we were to edit that, it would be easier to calculate that, that rate of change, but all intents and purposes, we only need to worry about the rate of change from positive to negative, or from negative to positive, so we'd be looking specifically at parameter b most of the time to answer question 4. On that note, that concludes all 4 of my questions. I hope you enjoyed the video, and I hope that this was a good demonstration of my skills using a computer-aided software and computer algebra software of GeoGebra Classic. I hope you enjoy the rest of your day, and thank you for watching.